I am Kavitha, Assistant Professor of Triple Department, Emmanuel J.J. College of Engineering. Today I am going to take the topic methods of voltage control. The following are the methods of voltage control: by static shunt capacitors, by static series capacitors, by static shunt reactors, by synchronous condensers. The other methods for voltage control are tap changing transformer, booster transformer, regulating transformer, and static bar compensators. First one, shunt capacitors. Shunt capacitor banks are used to supply reactive power at both transmission and distribution levels. Capacitors are either directly connected to a bus bar or to the tertiary winding of a main transformer. Shunt capacitors are used across an inductive load so as to supply reactive volt, thereby maintaining the voltage across the load. Shunt capacitors are extensively used in industrial and utility systems. This is the equivalent circuit. These are the advantages: less costly, it is flexibility of installation and operation. Next one, power factor improvement. Efficiency of transmission and distribution of power is high. Then single or multiple banks, industrial distribution and low and medium voltage substation. Reactive power is compensated. Then disadvantages: they cannot be overloaded. Reactive power supplied by static capacitors tends to decrease in case of voltage dip on the bus, whereas KVR proportional to V square. What are the problems associated with shunt capacitors? Switching inrush currents at higher frequencies and switching over voltages. Then limitations of harmonic current loadings. Possibility of self-excitation of motors when improperly applied as power factor improvement capacitors switched with motors. And applications of using shunt capacitor to distribution and transmission system. Distribution system, it improves power factor and improves feeder voltage control. Shunt capacitors are used in transmission lines for voltage regulation and to reduce the power loss. Then series capacitors. Series capacitors is connected in series to compensate the inductive reactance of line. It reduces the transfer reactance between the buses to which line connected. It increases maximum power that can be transmitted and reduces reactive power loss. The reactive power produced by the series capacitor also increases with increase in power transfer. Series capacitor is self-regulating in this regard. The locations of the series capacitors are midpoint of the line and line terminals. The voltage drop across the line is voltage developed is IR cos pi r plus I into XL minus XC sin phi r. This is the vector diagram. The voltage drop produced by inductive load can be reduced particularly when the line has a high X by R ratio. And what are the problems associated with series capacitors? Means locking of synchronous motor during starting, then hunting of synchronous motor at light load due to high R by X ratio. Ferroresonance occurs between transformers and series capacitors, which produces harmonic over voltages. The advantages is to improve voltage regulation of distribution and industrial feeders, then to reduce light flicker problems and improve system stability. What are the applications of series capacitors? First one, voltage rise due to reactive current by passing the capacitor during faults and reinsertion after fault clearing. Next one, shunt reactors. Shunt reactors are used to reduce or limit voltage rise due to open circuit or light load. Shunt reactor absorbs reactive power, are usually used for EHV lines longer than the far end line is open. Then advantages. Shunt reactors of sufficient size is permanently connected to the line. Fundamental frequency temporary over voltages to limit switching transients to maintain normal voltage under line load conditions. Next one, synchronous condenser. A synchronous motor running at no load feeds positive was into the line under over excited conditions and feeds negative was when under excited. A machine that running is called a synchronous condenser. Synchronous condenser connected in parallel so as to provide constant voltage in that particular point. Synchronous condenser absorbs reactive power in under excited conditions. It will act as an inductor. Synchronous condenser have been used for normal voltage control. Advantages. Reactive power production is not affected by system voltage, flexibility of operation at all load conditions. It is used in HVDC converter stations. It improves system stability. The disadvantages is installation cost is high, can fall out of step, which may result in a large sudden change in voltage, and the machine add to the short circuit capacity of the system during fault condition. Synchronous compensators cannot be designed to work at more than about 20 kV. This is the main methods of voltage control. Thank you.